Welcome to the ultimate prompt engineering masterclass. Listen, whether you're a student trying to generate better study notes, a developer building out complex AI apps, a content creator writing scripts, or an entrepreneur trying to automate your workflows, this explainer is your complete definitive guide to mastering what is absolutely the digital skill of the future. Today, we're going to take you from being just a casual AI user and transform you into a strategic prompt engineer. We'll explore exactly how the experts are using models like ChatGPT, Gemini, and Claude to create, much smarter results, way faster than ever before. So grab a notepad because we are diving right in. Okay, if you've ever used an AI chatbot, I can almost guarantee you've asked yourself this exact question. Why do some AI prompts generate absolute magic while others just completely fail? It's honestly incredibly frustrating. You type in what feels like a perfectly clear instruction, right? And the AI spits back something generic or inaccurate or completely off topic. But then you go online and you see experts generating entire coded applications or flawless data analysis in seconds. The secret? The difference actually isn't the AI model they're using. The difference is that they aren't just typing questions into a chat box. They are architecting reliable instructions. So here is our roadmap for today. First, we'll cover the art of the prompt, then foundational prompting techniques. Third is mastering chain of thought. Fourth, system prompts and constraints. Fifth, we'll get into the prefix tuning revolution. And finally, building production-ready workflows. Let's kick things off with Section 1, the art of the prompt, moving beyond basic questions. To really understand why this has become the single most in-demand AI skill out there, we kind of need to rethink how we talk to computers entirely. Google Cloud defines prompt engineering as the art and science of designing and optimizing instructions to guide AI models toward generating reliable, desired responses. Notice a couple of keywords there: optimizing instructions and reliable. See, a prompt is not just a simple Google search query. When you're using a large language model, your prompt is actually a crucial roadmap. It provides the context, the constraints, and the examples that literally steer the AI's output. So the quality of your prompt directly and immediately dictates the quality of what you get back. Moving from the playground to production is just this massive mindset shift. In the playground environment, you might be totally happy with a clever one-off answer. It's fun, it's experimental. But if you try to plug that into a real business workflow, you're in for a wild ride of inconsistent formats and tone drift. Production-level engineering, a concept heavily highlighted by the experts at Mind Studio, is about getting structured, reliable, and testable output every single time. It's about ensuring that if you ask the AI for a 2-sentence JSON summary, you never, ever get 6 sentences of plain text. Moving right along to Section 2. Foundational prompting techniques, the building blocks of AI communication. These are the core methods that professionals rely on every single day. The two most fundamental approaches you'll hear about are zero-shot and few-shot prompting. Zero-shot is basically what beginners do. It's direct instruction with 0 examples, like just saying, write a YouTube script or debug this code. And hey, it works okay for simple tasks. But when the output format really matters, we upgrade to few-shot prompting. This is where you actually provide the model with examples of correct input-output pairs before you ask it to do the task. By giving it these examples, you drastically increase the reliability of the model's formatting, tone, and logic. You aren't just describing what you want anymore, you're actively showing it. And here's a crucial point to remember. Prompt engineering is highly iterative. A great way to structure this is the DARE framework. It stands for define the task clearly, ask the model, refine your instruction based on whatever it inevitably gets wrong the first time, and examine the output again. Small, tiny tweaks in your wording, your structure, and your clarity can completely transform the quality of your AI-generated results. Seriously, never expect your first prompt to be your best prompt. It's a process. All right, Section 3, mastering chain of thought, giving the AI a working memory. Let's see how this builds into something even more powerful. Large language models are, at their core, highly advanced prediction engines, just guessing the next word. Because of that, if you ask them a really complex math or logic question, they sometimes rush to guess the final answer and get it completely wrong. Chain of thought prompting solves this. It forces the model to decompose the complex problem, generate intermediate reasoning steps, and only then output the final answer. Simply adding a phrase like, let's think step by step, literally forces the AI to write out its logic. This acts almost like a working memory it can reference, which drastically improves its accuracy. It's a total game changer. Now look at the empirical data proving how well this actually works.
Google Research tested a massive AI model, the PaLM 540B model, on grade school math word problems. With standard prompting, the performance was okay. But when they used the exact same model with chain-of-thought prompting, providing just 8 examples, it achieved state-of-the-art accuracy. It actually beat out models that were specifically fine-tuned just for math. It's an absolutely incredible leap in performance, and it all comes from just changing the prompt structure. No new coding required.
However, there is a fascinating caveat here that researchers found. This magical ability to generate coherent, step-by-step reasoning primarily arises in models of a massive scale, specifically models with over 100 billion parameters. Parameters are essentially the neural connections in the AI's brain. Smaller models might try to think step by step, but they often hallucinate or lose the thread halfway through. So, knowing the actual scale and capability of the model you are working with is a totally crucial part of being a good prompt engineer. Section 4. System Prompts and Constraints. Setting the AI's operating instructions. If you're a developer or a business owner looking to build custom AI applications, this is where the real magic happens. When building an AI tool, there are actually 2 levels of prompting happening at the exact same time. First, you have the system prompt. This is the invisible framework set up by the developer. It provides the persistent context, establishes the AI's role, and sets strict behavioral boundaries. Then you have the user prompt. That's the dynamic, immediate query typed in by the end user. The system prompt ensures that no matter what crazy thing the user asks, the AI maintains its specific persona, its expertise, and most importantly, its safety constraints. It's truly the operating system of the entire conversation. Tetrat provides this really excellent example of a strong system prompt. Instead of just using the default, "You are a helpful assistant," you say something like, "You are a technical documentation specialist with expertise in API design and developer experience." Why does this matter? Well, this hyper-specific role acts as a strong prior. It searches through the model's massive training data and activates the exact professional vocabulary, the right tone, and the precise level of detail required for that specific job. It ensures expert-level output right out of the gate. Moving on to Section 5, the prefix tuning revolution, steering without fine-tuning. Okay, we are now ascending to the expert research level stuff. Stanford University researchers illustrated a massive breakthrough here. Traditionally, making an AI great at a highly specific task required fine-tuning. Think of fine-tuning as performing expensive, complex brain surgery on the AI to teach it a new skill. You're updating everything. But then came prefix tuning. Instead of changing the AI's massive brain, researchers just freeze it, and they mathematically optimize a tiny prefix of virtual tokens. It's essentially like giving the AI a specialized pair of glosses that seamlessly guides its output without changing its underlying structure at all. And the results of this technique? Staggering. Prefix tuning requires storing 1,000 times fewer parameters than full fine-tuning, while maintaining comparable performance on full datasets. This is huge. It means you can have one single massive AI model sitting in the cloud, and you can steer it to do hundreds of different highly specific tasks just by swapping out these tiny, mathematically optimized prefixes. It's incredibly efficient. Just to ground this advanced concept for a second, look at this table-to-text example involving a coffee shop. The AI is fed a raw, clunky string of data about a place called Clowns. The invisible prefix effectively guides the frozen AI model to perfectly extract that raw data and generate a smooth, readable sentence, like Clowns is a coffee shop in the Riverside area near Clare Hall. It proves beyond a shadow of a doubt that we can get fine-grained control over generated content without rebuilding the brain of the AI every single time. All right, our final section, Section 6, Building Production-Ready Workflows, putting it all together. So how do we actually put all these foundational and advanced concepts together to build true AI agents and automated workflows? Well, building for production means treating prompt engineering way more like traditional programming than creative writing. You absolutely must specify strict constraints, literally telling the model exactly what not to do. You have to explicitly handle edge cases, defining what the AI should say if it simply doesn't know the answer. You must carefully control context windows, ensuring the AI only has the relevant information it actually needs. And above all else, you have to systematically test the outputs against real-world inputs. If your prompt can't handle unexpected user behavior, your application is going to break. Period. I really want to highlight this crucial insight from the team at Mind Studio. They say writing prompts without a test set is equivalent to writing code without tests. It might seem to work perfectly when you try it once or twice in the playground, but you have no idea where or when it's going to break out in the wild. A true prompt engineer builds a test set of diverse inputs and runs them before and after every single prompt change. That is how you guarantee stability and prevent regressions. We've covered a lot today: the art of communication, the foundational techniques, the complex reasoning frameworks, and the production mindsets that truly separate casual users from industry experts. Prompt engineering is the critical interface layer between human intent and artificial intelligence. So I'm going to leave you with this final provocative question. Are you ready to stop just talking to AI and start actually engineering it? Take these techniques, apply them to your own workflows today, and start building the future. Thanks for joining this masterclass.